My dear students, I welcome all of you for this session on Internet of Things. In this session, let me see how we can install the Arduino software. That is, how we can install Arduino IDE to Windows or Linux or Mac. Also in this session, let me have a look at fundamentals of Arduino programming. I mean, like any programming language, here we'll see what may be the basic structure of Arduino programming, what are the constants available in Arduino programming, okay, how to define a function in Arduino programming, what are the flow control statements we have in Arduino programming, and other controls. Okay, so let us have a look at agenda of this session. At first, we'll start with the installation of this software, that is Arduino IDE. Okay, so now after installing Arduino IDE to my computer, okay, let us see how we can connect an Arduino microcontroller to this computer, to which I have installed Arduino IDE. Okay. Also, in this section, after connecting an Arduino IDE, after connecting an Arduino Uno to computer with Arduino IDE installed, we will see how we can write a code, how we can compile, and how we can upload to controller. Next, let me have some look at some fundamentals of Arduino programming. As I said, like any other programming language, we will have a look at constants available, control statements available, the syntax of function definitions, and some other constructs. Okay. Also, we know that there are 14 digital pins, 6 analog pins, 6 PWM pins, right? We'll see what actually analog digital PWM means and we'll differentiate them. Okay. Now, how to install this software, Arduino IDE. I said integrated development environment, that is an Arduino IDE, is where we develop our programs, right? Right. Through an IDE, we develop our programs. I mean to say the programs that we will upload to Arduino means the program that will tell Arduino what to do. Got it? So what actually Arduino IDE is a software through which we develop programs that will instruct Arduino what to do. Okay. Now, after developing our programs using an Arduino IDE, this compiled program should be uploaded to the main chip, that is Atmega 328P. Okay, to upload what I said, you should connect the Arduino controller to computer using USB cable. Okay. Now, say assume your platform might be a Windows or maybe a Linux or a Mac. Okay, I'll tell you from where you can download Arduino. So now, as you can see on the slide, there's an hyperlink https colon slash slash www.arduino.cc slash en slash main slash software. Okay, just click on that hyperlink. So when you click on that hyperlink, you will be redirected to Arduino home page, which is seems to be like this. Okay, so see, just look at the slide at right side of the slide. See the various options for download. See, I mean, you can see options to download for Windows, to download for Linux, to download for Mac. Also, it is available in 32 bits, 64 bits. Clear? So now, just based on your platform, whether it's a Windows or Linux or Mac, okay, download the appropriate IDE by clicking on it. So once you download the Arduino IDE, to install, it's a normal procedure. Everyone know how to install software, right? So at first it will ask you to accept some terms and condition. You need to check the box. Later you need to just click on next, next, next until last button named finish appears. Got it? So I assume, okay, through this options you can download Arduino and you will install Arduino IDE yourself. Now I will assume you have installed Arduino IDE. Clear? So after installing an Arduino IDE, now you start launch this IDE. You launch Arduino IDE. When you launch an Arduino IDE, okay, you will see something, some window which appears like the one you can see on the slide. Okay, got it? When you launch an Arduino IDE for the first time, assume for the first time, you will see the window that is shown in the slide. Got it? So as you can see on the slide, already in a coding part, there are two functions named setup and loop. Okay, and let me tell you at now, let me tell you, this is the basic structure of any Arduino programming. So I repeat, the structure, the two with two methods, setup and loop, is the basic structure of Arduino programming. Okay. So now, see, still no, assume you have written, developed on program. Okay, you have developed on source code. Now, after developing the source code, you need to know how to compile it. Right. So once you have compiled, you need to know how to upload to Arduino board. Clear? And apart from that, you might be creating a source code. Okay. Something you want to save. So how to make save? Next, suppose you want to develop one more source code. You want to open a new editor, right? New tab for coding section. So there are some options available in this IDE. So let us look at that particular options. Okay. See, as you can see, the first button, that is there's something as verify. Verify button means you have written a program and to compile it. Okay, you need to compile. When you compile, if it is error free, okay, you can next you can upload to Arduino. So the first button is that's verify is for compiling. That is for debugging errors. The next button shown as upload button is to load the code to the microcontroller. And open file, it's very clear to open a new code window. Next, save. Once we have written a program, okay, we need to, as usual, we need to save the program. Okay, then there's something as serial monitor button. Okay, now before that, okay, and at the bottom of the window, you used to see there's something written as Arduino Uno COM3. So what actually Arduino Uno COM3 means? Okay, so this is an Arduino IDE, right? I said there are several variants of Arduino. Clear? So which Arduino board you have connected to computer? That is displayed. Here, in this case, we have connected Arduino Uno, so it's showing Arduino Uno is the board. And see, there are serial ports, one or more serial ports available. Okay, on your computer. So, to which serial port you have connected Arduino Uno? That is shown as COM3 in this case. Okay, COM3 is a serial port to which Arduino Uno is connected. So before that, there were see, after loading an IDE and before writing a code, okay, we need to follow some two more steps. Let me come back to that. See, this is after installing IDE and launching IDE for the first time. Got it? So we can see in text editor the basic structure with two methods, setup and loop, with body empty. I mean no coding. Okay. So next, the first thing. Okay. Now, first you need to make sure. Okay. Uh, you need to make sure. Okay. The Arduino IDE is selected the right board you are using. The Arduino IDE is selected right board you are using. Okay. Means here for your computer you might have connected two or more microcontrollers. Okay, two or more microcontrollers. So you need to be sure that the IDE is configured to Arduino Uno now. Okay, the board, I mean to say board that is selected is Arduino Uno. So for that you need to click on tools. You need to go for an icon board, Arduino Uno, and then Arduino Uno. Sometimes you might have interfaced to Arduino Uno, right? I assume you might have interfaced connected to Arduino Uno boards. But two Arduino Uno boards to computer through two different serial ports. Okay. After writing a code to which Arduino board among two boards, you need to upload the code, right? I mean, suppose two Arduino boards are connected. Of those two Arduino boards, you need to upload the source code to one controller, right? So you need to be clear with the serial port the Arduino is interface to computer. You need to be clear with the serial port of the computer through which Arduino is interfaced. So clarify the port of the Arduino board connected to computer. In this case, it's COM3 port. Okay. See here the tools under tools port we are selecting COM3 because there might be another serial port COM1 or COM2 for which some other Arduino boards might be connected to. But in this case, I need to upload the code to Arduino connected to COM3. So I need to make sure this in Arduino IDE. So this I said, right? So at the bottom of this window, the Arduino Uno is the board I am using, and COM3 is the port to which Arduino Uno is connected. Clear? Now we'll have a look at some technical specifications of Arduino Uno. I said the microcontroller on Arduino Uno is Atmega 328P. It's an Atmel register controller, right? Clear. So microcontroller is Atmega 328P. What about operating voltage? It's 5 volts. Means to power on Arduino, it should be supplied with 5 volts. So input voltage, the recommended is 7 to 12 volts. Input voltage limit is 6 to 20 volts. And I think we in the previous session, okay, while exploring the Arduino Uno board, you observe there are 14 digital I/O pins. Is it? There are 14 digital I/O pins, of which 6 provide PWM, that is pulse width modulation output. So there are 6 PWM digital I/O pins. So we know there are 6 analog pins labeled as A0, A1, A2, A3, A4, A5, and this we have seen in the previous session while exploring Arduino Uno board. The DC current per I/O pin is 20 milliamps. DC current for 3.3 volt pin is 50 milliamps. Also, I said the microcontroller has a 32 KB flash memory within it. Okay, or among that of which 0.5 KB is used by bootloader. See, there's a 32 KB flash memory inbuilt, of which 0.5 KB used by bootloader. There's a 2 KB static RAM, 1 KB electrically erasable programmable read-only memory EEPROM, 16 megahertz clock speed, and LED built-in. I said while exploring Arduino Uno, I said there was an LED pin interface to digital pin number 13. There is a built-in LED. Okay. The length of Arduino board is 68.6 mm, width is 53.4 mm, and the weight approximately 25 grams. This is about technical specifications of Arduino Uno. Now, let us have a look at fundamentals of Arduino programming. See, first look at the slide, okay? At left side, you can see something, no structure. I have highlighted as a structure. So this structure shows two functions named setup and loop. Is it? I mean, in the structure you can see two functions named setup and loop. So the basic, I mean to say, the basic structure of any Arduino programming contains these two methods, two functions. So here, the setup function, okay, is listen cautiously. The setup functions is always executed only once. Okay, when you turn on Arduino, the setup function will execute only once. So setup function usually used to configure, used to initialize the microcontroller. Setup function is used to initialize, configure the microcontroller. I means among digital I/O pins, the 14 digital I/O pins, right? Suppose I want to use some pins for input purpose and some pins for output purpose. I need to specify that in setup function. Got it? And the next function, name loop, the name itself says it keeps on repeating again and again. Okay, see here, the loop function keeps repeated invocation. It exists again and again until the Arduino is turned off. As long as Arduino is in power, on state, loop keeps executing. Okay, so now very clear, right? The basic structure of Arduino program contains two methods or two functions, that is setup and loop. Setup exists only once when Arduino is powered on and is used to configure, initialize microcontroller. Loop, as the name states, it keeps executing again and again until as long as the power is supplied to Arduino. Next, just have a look at setup function. One example I have taken. In the setup function, there is one statement, pin mode. Pin mode is a statement which invokes the function pin mode with two parameters. One is labeled pin, the other one is labeled input. Okay, what is said, just as an example I said, right, setup and setup function, I can specify which among the 14 digital pins I can use for input purpose, or which among the 14 digital pins I can use for output purpose, right? So those pin numbers I need to specify as first parameter for pin mode. Okay, pin number I need to specify as first parameter for pin mode function. Okay, and the second parameter here in this case, what I have used an uppercase. Okay, input. Okay, it configures the pin labeled as PIN as an input, okay, to the microcontroller. Okay, and here the input, the word input in uppercase is a constant. We'll see that it's a constant. Now let us look at loop. Okay, so what is in this? I've taken an example. Okay, something one example. Okay, for loop, and the coding codes are as per digital write pin comma I, delay 10,000, digital write pin comma low, delay 10,000. Okay, I mean see uh, here in this case one pin labeled as PN, okay, is configured as output. In this example, the labeled pin as PIN is configured as output. So for that pin, we can write some values either high or low, or in terms of 0 or 1, or in terms of voltage means 5 volts or 0 volts. Okay, clear. So this example shows that the pin labeled as PIN will receive 1, and after delay will receive 0. Got it? Then loop terminates. Again loop executes. When loop executes, first it will write I, then calls for a delay, then writes low, then again calls for a delay. It means suppose assume for the pin labeled PIN, assume you have interfaced an LED. Then this code, what it does, it keeps blinking an LED. It keeps blinking an LED. Okay, so this is about setup and loop. Now in general, apart from this setup and loop, we can have our own functions. Okay, and the function prototype is something like you can see on the slide. First one is type, that is return type. Okay, return type followed by name of the function, that is function name in this case, with the brace parameters. The same prototype will follow in C language too. Now let us look at some constants available in Arduino programming. You know, constant means value, variable whose value does not change during execution. Okay, here there are some predefined constants. One, as you can see, the constants labeled true or false. Okay, true means always true, false means false. If any condition is false, okay, we can check it. If any condition is true, we can check through the constant true. See, the first two constants are true, false. Also, we have constants input, output. So, input, output. I said through pin mode method, I can configure any of the digital pin as an input or as an output as I require. Okay, so the keywords input, output are constants. Also, we have the other keywords I low. So I low a keyword which are constants. Okay, when we write I to any digital pin, okay, it means we are writing a value 1. When you write the keyword load to any digital pin, it means we are writing value 0 to digital pin. Okay, I low means 1 or 0. Or alternatively, in terms of volts, I means 5 volts, low means 0 volts. In terms of on-off state, I means in on state or low means in off state. Next, some control statements. See, like in any programming language, like C, C++, Java, we do have control statements. See, here I've shown two control statements in the slide. One is say a simple if, the other one is if else. So in simple if condition is true, exit the body of if. Right? Clear? So if some variable equal to value, do the statements. In if else, if the condition is true, true block is going to execute. If the condition is false, else block is going to execute. Clear? So if else you're familiar in C and C++, Java, the same syntax here. Next, for. So we know a looping statement for. Okay, apart from for, we also know while, do while, right? The same looping statements we have in Arduino programming also. Clear? And the syntax of for, while, do while all are same as C in Arduino programming. For example, you can see the syntax of for initialization, semicolon, condition, semicolon, expression. So initialization, it exists once. Condition is true, then do something, that is the body of for is going to execute. Then expression is evaluated, then comes back to condition. Clear? And this is just an example. Next, while, do while. We know while what it does, it executes the expressions inside a parenthesis. That is, while loop executes its body until condition becomes false. Or as long as condition is true, the body of while loop executes. Do while. Do while is a bottom testing. Means we know, right, in do while, first the body of the while, do while will execute, then condition is evaluated. So we know in do while at least once the body of do while loop is going to execute. So there are some methods. Okay, we will have a look. Pin mode. See, pin mode method is to configure some pin as input or output. Okay, the pin to be configured as input or output should be the first parameter, and mode here is a constant, either input or output. Next, the next method, digital read. Okay, digital read means, see, suppose one pin is configured as input. Okay, its value can be read. Its value might be either 0 or 1. That value your microcontroller can read. For that, I need to use method digital read. Next, digital write. Okay, see, some pin labeled, some pin might be configured as output. Okay, for that pin I can write either value I or values low, either value I or value low, okay, through digital write. So it's very important functions: analog read, analog write. Analog read, okay, reads, see, there are six analog pins, right, labeled A0 through A5. Okay, we can the microcontroller can read value of a specified analog pin through this function. Got it? The microcontroller can read a value of specified analog pin through this function. Now, analog write, okay, writes an analog value using pulse width modulation to a pin marked PWM works. So I repeat, analog write, okay, analog write writes an analog value for PWM pins. Okay, so analog writes an analog value for PWM pins. So now let us have a look at difference between analog, digital and PWM pins. Analog pins. These pins have unlimited possible states between 0 and 1023. And these pins are used, allows us to read sensor values. Okay, in analog pins they have unlimited states between 0 and 1023 used to read sensor values. Say for example, you have interfaced a light sensor to one of the analog pin. If the room is very dark, okay, this pin will have the value 1023. If the room is very bright, we will read 0. If the brightness is between dark and very bright, the value read will be between 0 and 1023. Digital pins, as the name says, digital, it's a binary. There are only two states. They are either on or off, high or low, 0 or 1, 5 volts or 0 volts. Got it? I mean, for example, if an LED is on, then a state is high, or 1 or 5 volt. If it is off, the state is low or 0 or 0 volt. Clear? So one thing you need to know difference between analog and digital pins. Analog has unlimited possible states between 0 and 1023, whereas digital pins has only two possible states on or off. Next, PWM pins, pulse width modulation pins. They are the digital pins, right? We have seen PWM pins while we explored Arduino Uno board. See, as they are digital pins, so their output may be either 0 or 5 volt. It's very clear because they are digital pins, either 0 or 5 volts. However, these pins can output fake intermediate voltage values between 0 and 5 volt. Okay, because they can perform pulse width modulation. PWM allows to simulate varying levels of power by oscillating the output voltage of the Arduino. Clear? So we have discussed about difference between analog, digital and PWM pins. So this is about this session. Let me wind up. Thank you for listening.